When mathematics started predicting reality, it began as an uncomfortable coincidence. Equations written on chalkboards were describing events before they were ever observed, not explaining the world after the fact, but anticipating it. To understand why this matters now, we need to look at how mathematics was once used. For centuries, math described reality. It modeled motion, measured space, and explained patterns we could already see. Observation came first. Equations followed. Math was a language, not a prophet. That balance quietly flipped. As data exploded and systems grew too complex to observe directly, scientists began trusting models more than measurements. Climate systems, financial markets, particle physics. Reality moved faster than experiments could keep up. Mathematics stepped in to fill the gap. The first signs were subtle. Predictions that seemed too precise. Patterns emerging in simulations before instruments detected them. Entire phenomena inferred from equations alone. At first, these results were treated cautiously. Then experiments confirmed them. Again and again, in physics, particles were discovered because equations demanded they exist. In astronomy, planets were found where math said they should be. In biology, population shifts appeared exactly where model predicted. Mathematics was no longer reacting to reality. It was leading it. This raised a disturbing possibility. What if reality is constrained by mathematical structure more than physical observation? What if equations are not just tools, but windows into how the universe must behave? Once mathematics began predicting reality, the role of human perception quietly diminished, and science crossed a threshold where belief followed numbers. Even when intuition protested, as predictive mathematics grew more powerful, its authority expanded beyond science. Economists trusted models to forecast crises. Engineers relied on simulations to approve structures never physically tested. Algorithms guided decisions where direct evidence was incomplete or delayed. This worked because mathematics excels at one thing humans struggle with: complexity. When systems involve millions of variables interacting at once, intuition fails. Models do not tire. They do not guess. They follow structure to its logical conclusion. The conflict emerged when predictions began to feel detached from lived experience. Models warned of financial collapse while markets soared. Climate projections clashed with short-term stability. Medical forecasts suggested outcomes that contradicted individual cases. The math was sound, but the reality felt wrong. This exposed a deeper tension. Mathematics predicts systems, not stories. It describes averages, probabilities, and trends. Humans live inside exceptions. When models are right in aggregate but wrong personally, trust fractures. Researchers responded by refining models further. More data, more parameters, more computation. Predictions grew sharper, but also more opaque. Few could understand how conclusions were reached. Mathematics became a black box, trusted because it worked, not because it was understood. Then came the unsettling discovery. In some domains, predictions alter the outcomes they described. Financial models influence markets. Risk forecasts change behavior. Climate projections reshape policy. Mathematics was no longer neutral. It was participatory. This feedback loop blurred cause and effect. Did the model predict the future or create it? When belief follows equations, reality adapts in response. The authority of mathematics was no longer just intellectual. It was causal. And once predictions begin shaping the world, the line between describing reality and deciding it starts to dissolve. The conflict reached its peak when mathematics began outperforming explanation. Models delivered accurate forecasts without offering intuitive reasons. They worked, but they did not tell stories humans could follow. In fields like climate science and epidemiology, decisions had to be made before outcomes unfolded. Waiting for proof meant waiting too long. Mathematics asked for trust in advance, not faith, but acceptance of probability over certainty. This unsettled the public. When predictions demanded sacrifice without visible cause, resistance followed. People questioned not just the conclusions, but the legitimacy of the models themselves. Mathematics, once neutral, became political. Inside research communities, a quieter concern emerged. Models are built on assumptions, simplifications, choices about what matters and what is not. When predictions carry power, those choices carry influence. Bias no longer hid in opinion. It hid in equations. Yet abandoning predictive math was impossible. The systems it described were too complex, the stakes too high. Humanity had crossed a point where acting without models meant acting blind. The emotional peak came when simulations revealed futures no one wanted to accept. Scenarios where small delays caused irreversible outcomes, where probabilities crossed thresholds beyond recovery. The math did not argue. It simply showed consequences. This forced a reckoning. Mathematics was not destiny, but it revealed constraint. It did not command action, but narrowed choice. Ignoring it did not preserve freedom. It surrendered it. Reality was no longer just what happened. It was what models warned could happen. And humanity stood between equations and experience, deciding which to trust. The resolution came with a shift in humility. Mathematics was never meant to replace reality. It was meant to reveal its boundaries. Predictive models did not remove uncertainty. They mapped it. Scientists learned to speak differently. Predictions became ranges, not certainties. Scenarios, not prophecies. Mathematics guided decisions without claiming authority over meaning or values. Numbers informed judgment, but did not replace it. The deeper lesson was cultural. Humans had to learn how to live with foresight. Seeing consequences before they arrive changes responsibility. When outcomes are predictable, inaction becomes a choice rather than an excuse. Mathematics did not steal agency. It sharpened it. It showed where paths led long before footsteps reached them. The future was no longer hidden. It was outlined, waiting for response. This did not make the world easier. It made it clearer. Hard decisions arrived sooner. Trade-offs became unavoidable. But clarity replaced surprise. When mathematics started predicting reality, it did not end mystery. It relocated it, from what will happen to how we will respond. And perhaps that is the quiet power of equations. Not that they tell us the future, but that they ask whether we are willing to face it. So, what do you think? Should we trust the numbers when they warn us, or wait until reality makes a lesson unavoidable?